Okay, so I just wanted to go over how to draw the structural formulas because I went over yesterday naming, and I don't want to leave drawing the structural formulas until next week when we might have forgotten about the steps. So there's going to be 3 different ways of drawing, and I'll show you all 3. I finally got a name for the lines that I use to draw. That's the skeletal formula. So we're going to start with pentane, something similar. Something simple, not similar. And for those of you that weren't here yesterday, so there is a way of naming organic compounds. We're dealing specifically with hydrocarbons at the moment, and hydrocarbons that contain only single bonds, which are called alkanes. I'll deal with double and triple bonds next week. And there's first there's a prefix that we use to to indicate how many carbon atoms there are in the compound. So if there's 1 carbon, the prefix is meth, 2 is eth, 3 prop, 4 bute, and then 5 to 10 is basically the same prefixes you use in geometry and the same prefixes we used in grade 10 when we named molecular compounds. So 5 is pent, 6 is hex, 7 is hept, 8 oct, 9 non, and 10 dec. So first thing, pentane. So I mentioned last week and again yesterday that the names of organic compounds are instructions on how to build them. And so this name would tell us 2 things. First, that it ends with A-N-E, ane, which means it's an alkane, which means they're all single bonds. So there are no double or triple bonds in this compound. And second, pent tells us that there are 5 carbons. So for today, I'm just going to go through the line bond structural formula, which is like the completely extended structural formula. Then I'll do the condensed, and then we'll do the skeletal, which is probably the version that you will use the most often because it's honestly the easiest to use. So the line bond structural formula is that completely where all of the hydrogens are shown, every single bond is shown. So the first thing you want to do, like I said, is look at the prefix pent. That tells you that there are 5 carbons. So I'm going to start doing that. 1, 2, 3, 4, 5. And then the rest of it, because it's a hydrocarbon and it's an alkane, which means there's all single bonds, that means every carbon is bonded to 4 other atoms. And we're not dealing with functional groups yet. And like I said, it's a hydrocarbon. That means that every other bond is a hydrogen atom. So this is the line bond structural formula for pentane. The condensed structural formula is going to be taking these groups and just putting them together and not showing all of the single bonds. So the condensed structural formula would start off CH3, that's the first group, and then single bond CH2, 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 CH3. Skeletal formula is drawing a zigzag line, and at every point of the zig or the zag, that represents a carbon atom. So for pentane, that's 5. You start counting the number of carbons as soon as the pen hits the paper. So that would be 1, 2, 3, 4, 5. That's called a skeletal formula. What we are assuming here is that every corner, including the ends, 1, 2, 3, 4, 5, every point is a carbon atom. And if you don't see any other chemical symbol or structure, then it is implied that hydrogen fills the rest of those bonds. So as I said, I think this will be the most commonly used method for drawing these formulas. We'll do a couple more examples. Octane. So again, it's ANE for the ending, which means it's all single bonds, and oct means 8. So here it's asking for the molecular formula. So the molecular formula is chemical formula, same thing. And that's when you go to the general formula I gave yesterday for alkanes, which is CnH2n plus 2. And oct tells you what N is. Oct tells you that N is 8. So the molecular formula would be C8H, and then 2 times 8 is 16 plus 2 is 18. C8H8, blah, blah. C8H18. Oh, say that 3 times fast. And then, of course, we get line bond structural formula. So you start off writing 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. And then everything is single bond. And you start to see why this is the least preferred method of drawing structural formulas, because 1, it takes forever, and 2, it takes up lots of space. Okay, that's octane. The next thing is drawing the condensed structural formula. So again, for alkanes only, each end is going to be a CH3. So we start with CH3, and then all of the carbons until the other end is going to be CH2. So then you just count how many carbons you're doing. So that's 2, 3, 4, 5, 6, 7, and now number 8 is our other end, so it's 3, CH3. The other way, if on any entrance exams or evaluation tests, things like that, when they do a condensed structural formula, if you do see something like this where all of the carbons in the middle are CH2s, then that automatically tells you that it's an alkane. So then all you have to do is count how many carbons there are, and then use the prefix with the suffix ane. When we get into double and triple bonds, you'll start seeing CHs in the middle, or even just a single carbon atom, and that will indicate that there's a double or triple bond there. And the last thing is the skeletal formula. Again, as soon as your pen hits the paper, you count 1, 2, 3, 4, 5, 6, 7, 8. See how easy that is? Bruh. That's why we like the skeletal formula. Now, reviewing from yesterday, when you have, this is your parent name. So when you see a structural formula, the first thing you want to do is identify the longest continuous carbon chain. That's your parent. That comes at the end of the name. Then all of these names that you, no, I don't want that. Go away. Go away. Okay. All of the names that you have in front, these are called alkyl groups. These are branches. Okay. So the line bond structural formula, you've got heptane. So we're going to start with the parent first. So that's 7 carbons. 1, 2, 3, 4, 5, 6, 7. Now I have to add my alkyl groups, my branches. Remember, meth, the prefix meth is 1 carbon, and eth is 2 carbons. And the numbers that come in front of those names indicate on which carbon the branches are. Now, ethyl is on number 4. So all I do is I count from left to right. 1, 2, 3, 4. So my ethyl group is here. So I draw 1, 2 more carbons there because ethyl is 2. And then my methyls, I've got 2 numbers, 2 and 3, and the die indicates that there are 2 methyl groups. 1 methyl group on number 2, 1 methyl group on number 3. So generally we try to keep this as neat as possible. So I'll do 1 methyl group here, 1 methyl group there, because methyl is 1 carbon. don't forget, for line bond structural formula, you have to fill in the rest of the carbons that indicate that carbon has all 4 bonds full. So you'd have to have H here, 3 hydrogens there, 1 more there, 1 more here, 3 there, 3 there. I'm not going to do this because it's going to take too long. So you just fill all the rest of those with hydrogen. Now, if you're going to condense this, I'll do this over here. You just, like I said, you keep them in groups. These are all the groups that you have. So it's CH3, CH2, CH, CH2, CH2, CH3. So I start with the first group, which is CH3. And then my second part of the chain in the parent is this group, which is CH. And now I have to do my first methyl group, which is here. So that goes up here, CH3. The third carbon in my parent is that one. So that's CH. And I do my second methyl group down here, CH3. The next, I guess I should have filled all those in. Okay, next one, where am I at? I'm here. So that's the next one on the chain, CH. And now I've got my ethyl group, which is going to be CH2, CH3. Then I've got this one and that one, both CH2. And finally, the ending CH3. Oops, 3. Okay, that's condensed structural formula. Now, skeletal. Here's how I would do skeletal. I go back to, let me erase that, back to the parent name, or not the parent name, but the name of the compound. And I start with the parent, heptane. So I'm going to draw heptane first. 1, 2, 3, 4, 5, 6, 7. Okay. Next, go up to my groups. I've got 2,3-dimethyl, 4-ethyl. So 2,3-dimethyl. I start counting from here. 1. I don't want to put that there. So it's number 1, 2, 3, 4. So I've got 2,3-dimethyl, 4-ethyl. Okay, again, each point or peak of the zigzag line is a carbon. So this is one carbon that represents a methyl group. This is one carbon that represents a methyl group. Here and here, one carbon each. So that is an ethyl group. Much easier to do it that way, right? So I'll do one more. I'm not going to do line bond because that's like, ugh. We'll do one more with, okay, yeah, I'll do line bond and whatever. Okay, octane, 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. 3,3-diethyl. So that means that there is an ethyl group on each side of the third carbon. So on number 3, I got to do 2 carbons up, 2 carbons down. And then you fill in the rest. See how messy that is? I hate that. And then, of course, there would be hydrogens everywhere. You get the picture, right? Okay, if I'm going to do the condensed structural, I'll just do that. Let me change the color. Green. Okay, so I'll take the first group, CH3. The next one is CH2. And then here's where it gets messy because my third carbon is completely by itself. But I've got an ethyl group on the top, which would be CH2 and then CH3. Same thing on the bottom, CH2, CH3. And then I've got 1, 2, 3, 4 more CH2s. 3, I'm going to run out of room. And then finally CH3. Okay, I really would not recommend using the line bond. I would, if you need to, use the condensed, but the easiest way to do it is to do the skeletal. So octane, 1, 2, 3, 4, 5, 6, 7, 8, 3,3-diethyl. Okay, so there's a couple ways you can do this. I didn't really leave myself much room. Let me try that again. I'll just erase that because we don't like that. Okay, so octane, 1, 2, 3, 4, 5, 6, 7, 8. And I need 2 ethyl groups on number 3. Like I said, there's a couple ways you can do this depending on what kind of aesthetic you prefer, what you think looks better. So this is number 3. So that means I have to have 2 ethyl groups on that one. You can either do dun, dun, like that, dun, dun, like that, or you can do one up here, one down there.